Hi everyone, so we started off fairly quickly into probability with the last video, and I just wanted to slow down a little bit and ask the question, how can probability be a number? And what do these numbers mean? So we came up with some probabilities in the last video, 5 over 14, 3 over 8. What do those numbers actually mean? How do they help us to see how likely these things are? So first of all, I want to start off with some English words. For example, impossible. Impossible, if something has a probability of 0 or 0%, that means that event is impossible. And we've got certain or definite. Now, something that's certain or definite has a probability of 1 or a 100%. And hopefully this makes sense. If the probability is 100%, it's 100% going to happen. You can hear people saying that. And there's a 0%, if there's a 0% chance, it's impossible. Okay, now when we go towards the things in the middle, in order to understand this properly, ideally, you'd be really good at converting between percentages, decimals, and fractions. But because not everybody is really good at that, we'll break it down a little bit. So 50% is halfway in between. That if something has a 50% probability, like flipping a coin, then it's just as likely that you get one outcome as the other. So it's just as likely that you get heads or tails. But 50% is actually also equal to 0.5. And in terms of fractions, it's equal to a half. Okay, so let's keep going. Let's say we had the probability from last time, which is 5 over 14. 5 over 14 is somewhere around here. So it's slightly less than 50% probability. And I'm just going to go to a calculator to convert that, because we all have calculators, we might as well use them. The fraction, and look, I have no internet. The fraction 5 over 14 can be converted into a decimal by simply just writing 5 divided by 14, because 5 over 14 is divided by. So that's now I've got a decimal 0.35. And if we want to convert that to a percentage, we times it by 100. Okay, so you can do this two-step process. Anytime you have a fraction probability and you want to work out what sort of percentage that is, you can divide the numbers to find the decimal and then multiply it by 100 to find the percentage. So it was around 36%, and we'll write that down. 36% around here. 0.36 roughly, and 5 over 14 was our actual fraction. And then we had 3 over 8, and I can just tell you that's a very similar probability actually. That's 37.5. So that'll be somewhere around here. So actually, even though these two fractions look very different, they're actually a very similar probability. Okay, let's move on. So now I want to talk about, for the majority of this video, I want to talk about Venn diagrams. So we'll also briefly talk about this idea of complements. So by the end of this video, hopefully you can solve problems by writing the sample space on a Venn diagram or using Venn diagrams. And we're going to eventually have some problems with two events at the same time. So event A and event B, and solving problems with that. But we're just going to start very simply with a problem that you might have seen before. A number is chosen at random from 1 to 10. And the question is, find the probability that it's bigger than 3. So now I'm going to make an event called bigger than 3, and I'm going to make a Venn diagram. Now, if I only have one event on my Venn diagram, this is not a Venn diagram that you have seen before. You will have seen these types of Venn diagrams before with two circles, but this is for two events. If I only have one event, I only have one circle. So this event is called bigger than 3. And this whole set is called numbers from 1 to 10. Now, what we can do, we can do one of two things. We can write all of the outcomes in the sample space onto this Venn diagram, or we can write how many numbers in each section there are. But I'm going to start off by writing every single item in the sample space, all the numbers from 1 to 10, on this Venn diagram. So now this area outside of the circle is the numbers that are not bigger than 3. And inside the circle is the numbers that are bigger than 3. So why don't we start off with the numbers that are bigger than 3? Well, we can't include 3, because that is 3. It's not bigger than 3. So we include 4, 5, 6, 7, 8, 9, and 10. And outside the circle, all the numbers that are not bigger than 3. So that would be 1, 2, and 3. Also, I don't know why I wrote commas here. You don't have to write commas. Okay, so that's all the numbers in the sample space in this diagram, and they're divided into two sections. Now, we've got an event called bigger than 3. Now, complements is the opposite of this event. So the complement of bigger than 3, not bigger than 3, that's talking about these three numbers outside of the circle. Okay, so finding the probability that it's bigger than 3, all we need to do is we need to find the number of successful outcomes, just like last time. Divide that by the total number of outcomes. And the successful outcomes are in the event, which is inside the circle. So how many are they? There's 1, 2, 3, 4, 5, 6, 7 of them. And the total number of outcomes is all of the outcomes in this set of numbers 1 to 10. So that's 10 numbers, of course. And that's it. That's our probability. Now, if we wanted to find out what that means in terms of percentages, we divide 7 by 10 and then times by 100, we'll get 70%. So it's more likely that you'll get a number bigger than 3. Now find the probability that's not bigger than 3. That's actually 1 minus this. Because the probability of getting a number 1 to 10, the whole thing is just 1. Or 100%. You've got a 100% chance of getting a number from 1 to 10 because you're choosing one. Of course, you're going to get a number from 1 to 10. Now this is just the rest of them, the rest of the probability. Some of it's 7 over 10 and the rest of it is the complement. So, I mean, we don't really need that for this particular question because we just count the number outside and that's our new successful outcomes. So there's 3 successful outcomes, 3 outcomes in the event that they're not bigger than 3, and 10 total outcomes again. So that's 3 over 10. All right, now we're going to go to the next level now, which is a Venn diagram with 2 events in it. And what that means is we have to draw circles, 2 circles. Now, we could draw the circles like this, but it's possible that there's numbers in both of our events. So we're just going to draw the circles like this, just in case there's a number in both of our events or a few numbers in both of our events. Okay, so let's make 2 events. One of them is bigger than 5, and the other one is even. So we'll call out 2 events, bigger than 5 and even, and the numbers in a sample space are from 1 to 9. Now we just need to put them in the right section. Now, first of all, are there any numbers that are bigger than 5 and also even? So let's do the middle section first. It's always best to do the middle section first because it's easiest. So bigger than 5 and even, that'll be the number 6 and the number 8. Okay, so now are there any other even numbers? Well, there's 2 and 4, and that's it. Now, are there any other numbers that are bigger than 5? Well, yes, there is not 5 itself, but 7 and 9. We've got to include 9. And finally, the rest of the numbers we put outside, so they're not bigger than 5 and they're also not even. So that would be the number 1, the number 3, and the number 5. And let's just count the numbers to see if we've got 9 numbers in total. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's good. All right. So find the probability that it's bigger than 5. Now for this one, we just use all of the numbers in this circle. That's both of these sections. Because all these 4 numbers are bigger than 5. So that would be the successful outcomes. There's 4 successful outcomes, which are 7, 9, 6, and 8. And the total number of outcomes, if I'm choosing a number from 1 to 9, is 9. What's the probability that it's even? Well, that will be the numbers in this circle. So that's these 4 numbers. 4, and that'll be 4 over 9 as well. Now, the real benefit of drawing these circles, drawing this Venn diagram, is that you can answer these trickier questions, which are, for example, find the probability that it's even, but not bigger than 5. Okay, now which are the numbers that are not bigger than 5? That would be all the numbers outside of this circle. See, I've shaded in everything except for this circle. All of these numbers that I've covered up with blue, they are not bigger than 5. So that's 2, 4, 1, 3, and 5. So it says find the probability that's even but not bigger than 5. So it also has to be even. So even numbers is this circle. So the only section which is even but not bigger than 5 is this one. So the numbers 2 and 4. So that's 2 successful outcomes here and 9 total outcomes. So that's the probability. Okay, and now one last slide we're going to look at, which is the terms and symbols in Venn diagrams. So let's say again we've got the situation, a number is chosen at random from 1 to 9. So we'll draw, and we've got 2 events this time. Event A is the number is bigger than 4, so we'll call that event A. And we'll call this one event B, that the number is even. Okay, so intersection means both events are at the same time. Well, okay, why don't we just put something in the Venn diagram and then we'll move on. But this time we're just going to put how many numbers are in each section. So you can see that there's 2 numbers in this section, 2 numbers in this section, and 2 numbers in this section. So I'm just going to write the number of numbers, the number of outcomes in each section. And we had 3 outcomes on the outside. So intersection means both events at the same time. So if we're finding probability A intersection B, that's both A and B. That would be this section in here. So the probability of A intersection B is, we've got 2 successful outcomes in here and 9 in total, so 2 over 9. Okay, so that's intersection. So whenever you see this symbol, intersection, that means if you've got 2 events, the middle section in here. Union is different. Now the best way to talk about union is to actually draw it. So I'll draw all the sections that are in the union. So union is either or both events. So that means it could be A, it could be B, or it could be both. So that's all of these ones. So if we're trying to find the probability of A union B, you have to add up all of these numbers. So 2 plus 2 plus 2. That's six outcomes in this section. And that means the probability is probability of A union B equals 6 over 9. All right. So just to recap, what have we learnt? We've learnt how probability can be a number, and it can be a percentage or a decimal or a fraction. And what those numbers mean, keep in mind that 1 is the highest possible probability if it's a decimal. You can't have a probability bigger than 1. So if you ever have a probability of 2, and by the way, some people get confused about this. Some people will go, okay, probability of A union B, A intersection B, well that's a 2 in here, so the probability is a 2, and that'll be the answer. But that's incorrect because, and you should remember that probabilities can't be bigger than 1. So if your probability is a 2, it's not right. And the problem is they've got the successful outcomes in here, but they forgot to make a fraction and divide that by the total number of outcomes. And if you find out what 2 over 9 is using a calculator, you'll work out it's between 0 and 1. It's 0.2222, whatever. So that would be somewhere around here. That would be around 22%. So that's the right answer. You can't have any probabilities bigger than 1. Okay, the next thing we learned is complements. If I have an event called bigger than 3, these numbers are in that event, and these numbers are in the complement, which is the opposite. Okay, then we learnt how to draw a very simple Venn diagram with only one event in it. And then we learned how to draw a more complicated Venn diagram, the normal one, with 2 events in it, with 2 circles, and you've got some outcomes that are in both events. And so we learned how to answer questions using that. And finally, we learnt some of these terminologies. Intersection, which is like an upside down U, means both events at the same time. Union, which is a U, a normal U, means either event or both of them, so it could be in any of these sections. And finally, to find the probability, as usual, you're still using the number of successful outcomes divided by the total number of outcomes. So here, the number of successful outcomes was all of these ones. That's 2 plus 2 plus 2, which is 6, divided by 9, the total outcomes. All right, I'm going to see you next time.